Right now, billions of people are sending messages, making phone calls, streaming videos, and accessing the internet. But have you ever wondered what actually happens between the moment information leaves one device and arrives at another? How does a voice travel from your smartphone to someone thousands of kilometers away? The answer lies in one of the most important concepts in RF engineering, the communication system. Humans constantly exchange information. We speak, send text messages, watch videos, browse websites, and communicate through countless digital services every day. However, information cannot magically move from one location to another. Imagine trying to send your voice from Berlin to New York. The information must somehow leave your device, travel through a communication medium, and arrive accurately at the destination. Along the way, it may encounter noise, interference, signal loss, and many other challenges. This creates a fundamental engineering problem. How can information be transferred reliably from a source to a destination? Solving this problem is the primary purpose of a communication system. A communication system is a collection of components that work together to transfer information from a source to a destination. The information may be voice, video, text, sensor data, or any other form of message. Regardless of the content, every communication system performs the same basic task, delivering information from one point to another. Most communication systems contain three major elements. First, there is a transmitter that prepares and sends the information. Second, there is a channel through which the information travels. Third, there is a receiver that captures the signal and reconstructs the original information. Although communication technologies have evolved dramatically over time, this fundamental structure remains the same in nearly every modern system. Intuitively, a communication system can be compared to a postal service. A sender writes a letter, the postal network transports it, and the recipient receives the message. The goal is to deliver information accurately despite various obstacles encountered during transport. Physically, consider a mobile phone call. Your voice is converted into electrical signals inside the phone. These signals are processed and transmitted through electromagnetic waves to a nearby base station. The information then travels through communication networks before eventually reaching another phone, where it is converted back into sound. Mathematically, communication systems can be viewed as information processing chains. Information is transformed into signals, transmitted through a channel, affected by noise and distortions, and then reconstructed at the receiver. Every communication technology follows this same fundamental process. Communication systems are the foundation of modern RF engineering. Nearly every RF technology exists to support the transfer of information between devices. Cellular networks use communication systems to connect billions of smartphones. Wi-Fi systems enable wireless internet access. Satellites transmit information across continents. Radar systems communicate information about object, location, and movement. Even simple wireless sensors rely on communication system principles. For RF engineers, understanding communication systems provides the big picture view of why transmitters, receivers, antennas, amplifiers, filters, and modulation techniques are necessary. These components are not isolated devices, they are building blocks within a larger communication system. Communication systems are among the most important engineering achievements in human history. They enable global connectivity, internet access, navigation systems, broadcasting, wireless networking, and countless other technologies that modern society depends upon. A common misconception is that communication engineering is primarily about hardware. In reality, communication systems involve information, signals, channels, noise, protocols, and system design working together to achieve reliable information transfer. Now that we understand the overall purpose of a communication system, the next step is to examine its internal structure. In the next lesson, we will explore the RF system block diagram and see how transmitters, channels, and receivers are organized within a complete communication chain. In this lesson, we learned that a communication system is a collection of components designed to transfer information from a source to a destination. We also explored the three fundamental elements of every communication system: the transmitter, the channel, and the receiver. In the next lesson, we will study the RF system block diagram and discover how these components are connected inside real-world communication systems. If you found this useful, like the video, subscribe, and follow for the next lesson.